Okay, then let me tell that I'm very honored to present the morning session. One of the particularity of this workshop is the fundamental use that not only matter will be treated, but also antimatter. And this is the morning session of the antimatter. Then I immediately give the words to Professor Santilli, who will start with the first talk of this section on antimatter, the dual theory of antimatter and this prediction of antigravity. Professor Ruggero Maria Santilli, okay.
Well, dear friends and colleagues, all of us, we are here as a kind of a privilege, at least for me, because to my knowledge, this is the first formal workshop on antimatter astrophysics. There is no other. Of course, we had all sorts of meetings in antimatter, even ourselves. We organized one in Cepino in 1996 with proceedings published in Holland. But as far as antimatter in astrophysics is the first one that I know. And I think it's way overdue because there are, now this is another lecture that I have enormous difficulties for outlining because it's the result of many, many years of work. So, and it's just for our way of treating antimatter in a quantitative way. And it's presented in this monograph with Springer. I apologize if I cannot be technical because the presentation is again, I have to present, some conceptual foundation and the mathematics. Unless we have a good mathematics, we will not be able to treat antimatter. This is a dream. After that, we have to look at the dynamics. After that, we have to look what is the central scope of this lecture, which is just a small, tiny introduction to the real thing. Excuse me. The real thing will be the next lecture by Professor Dehaene, namely on experiments. So what are the implications of this? Why we believe this experiment measuring the gravity of the positron is important. And then, of course, some concluding remarks. So my lecture is kind of an introduction to Professor Dehaene lecture. So let's see. I always had extreme uneasiness in accepting. Sorry, my voice is gone from yesterday. I have extreme uneasiness in accepting 20th century view in antimatter. Why? Because I accept the view by Karl Popper and other philosophers of science outside organized interest, in which antimatter represents one of the biggest scientific imbalances, one of the biggest scientific imbalances of the 20th century. Why? Because matter is treated at all levels, from Newton to second quantization, and antimatter only at the level of second quantization. I'm a democratic person. I will never ever accept this because matter and antimatter have to be treated on equal footing. I want to see antimatter beginning at Newton, and then I want to see Newton's equation for antiparticles, and then go up. You cannot do this today because the only way to change matter to antimatter in Newton is the charge, which assuming that you can represent the charge. I'm interested in representing a neutral particle of antimatter, such as the pi zero, I'm sorry, no, such as, little asteroid or whatever. Anyhow, why this imbalance? The imbalance is because Einstein theory, both special and general relativity, have no quantitative mean, none, to do any calculations, particularly at the classical level. Namely, you know the Casimir invariant of special relativity. There is no conjugation here. Those are for matter. Then you look at the field equation in gravitation. Is there any conjugation? Well, there may be a conjugation in the source tensor on the right-hand side, but it's the charge. And so you see here a structural inability to represent the gravitational field of a neutral astrophysics object, such as a star that we have to assume, or a planet that we have to assume to be neutral, otherwise we do. In any case, the charge will have a very, very small gravitational meaning. Now, as I did in the preceding day, in the preceding several interventions, I want and I intend to defend Einstein. Einstein is justly, a pillar of 20th century science. I have to defend Einstein. This imbalance is due to what we call, it's called now everywhere, Einstein followers. Because antimatter was discovered, 15, 20 years after the formulation of both special and general relativity. So that's why Einstein is one of the most abused names in the history of science. Einstein followers that say, basically their position is, since Einstein theory do not predict antimatter, antimatter does not exist except in a very, very small, very, very small part, or some peculiarity. Even in the universe, if you look now at the cosmological view, there are no antimatter galaxies. Well, we will see whether this is true or false. So it's a political stand, not a scientific stand. The scientific stand is that special and general relativity have no quantitative means for the treatment at a classical level necessarily, and neutral antimatter, just fundamental for any. Then you can add the charge. Now, the dismissal of this posture, I call it a posture by Einstein followers, who abuse of, in my view, of Einstein name, has to be dismissed for our own security. Because they say antimatter doesn't exist. The Earth has been devastated in the past by antimatter asteroids. This is the Tunguska explosion in 1908. You have read all sorts of political interpretation. Oh, no, it was a comet, because they have they don't say so, but they want to maintain Einstein prediction, their prediction in the abuse of Einstein theory that there is no antimatter. In reality, we're talking about an explosion equivalent to 1,000 atomic bombs that left absolutely no crater whatsoever, none. So it can only be explained by the annihilation. Even assuming this was a comet made of water, just the weight of the water would have collapsed entire Siberia. In any case, this alternative, the only quantitative solution is antimatter asteroids. Why? Because the entire atmosphere of Earth was excited for 2 days. In Sydney, Australia, people were reading newspaper at midnight. In London, it's on record, the official record. only annihilation in enormous amount explained this excitation of the entire Earth atmosphere all over the globe. But even a few years ago, I don't know whether you have noticed, maybe it was covered by the CIA or whatever, distorted, but there was announcement in CNN of an enormous explosion in the sky south of the Cape of Buona Speranza in South Africa. Ladies and gentlemen, I don't think that the Israeli exploded a bomb in the sky there. No. This will not be. Or some other nation, I don't know, the Indian exploded an atomic bomb. No. This is not the case. Or America. No. It was an antimatter asteroid that, thanks God, was not big enough so that the explosion occurred, was enormous, but nevertheless did not create a tsunami. Because if it had created a tsunami, would have killed people 1,000. This is a picture from NASA in which you can only, at this very high level, this can only be explained as an antimatter, a little antimatter asteroid. This is what you see in I've been looking at this for years and years. This is dust. I want to express to you my doubts, because why is it so dark? Why this thing is so dark when there is so much light and stars in the back? Sure, of course, it's plausible that this is dust of matter, but ladies and gentlemen, as we will see from the calculation, this could be antimatter that we cannot see with conventional methods. This will be the next talk about. Okay, let's go to the. So what is the need? The basic need is mathematics. Unless how do we treat matter? We treat matter with sinus, cosinus, tangent, differential calculus, Newton, and Leibniz, etc. Now, this is excellent for matter. If we want, what is our task? To treat matter at the classical, beginning from a classical neutral antimatter particle. We need a mathematics, we need a conjugation. So I need a sinus, a cosinus, a differential calculus that is conjugate to that which we use in the 20th century for matter. This mathematics did not exist. So I had to be built. I was at Harvard. My colleague Shlomo Sternberg, a very good friend of mine, I had major discussion with him. He said, Ruggero, no, they don't that. He showed me all sorts of conjugation but of mathematics available, but none of them I could use to represent antimatter. So I had to sit down. This was a very laborious work that took many years. The solution was the most elementary of them all. You have to go to the very, very ultimate root of knowledge. The unit is the fundamental. You cannot go deeper than that. So I said, okay, let's assume that the basic unit is -1 and build the mathematics based on that -1. That's what essentially which I did. But I delivered a talk at a purely mathematical meetings in Palermo a few years ago, invited by the Rendiconti there. I had a 15-minute slot. So I presented the big screen, I presented this, I made the statement, I'm interested in building mathematics based on this unit. There was what we say in Italian, putiferio. There was a moment of total silence. And then they start raising each other, asking questions, fighting among each other. This is the only transparency I could project. My 15 minutes went away, and I could never go to the second level. Because this indicates the conviction that by mathematicians, that, all possible mathematics exist. My God, this is absolutely not true. Anyhow, but there is something deeper than this. The deeper is this. What is charge conjugation? Well, it's an anti-hermiticity. And so the real map in which we build our mathematics is also anti-Hermitian. But this occurs only in a Hilbert space, while this occurs beginning from Newton on, actually beginning from Newton, numbers, fields, sinus, cosinus, all the way. So, but you should remember this, because we call this map isoduality, is equivalent to charge conjugation. However, equivalent to charge conjugation only when we do quantum mechanics. Otherwise, at the classical level, there is no equivalence. Also, there is something very deep here that you should keep in mind, and this Professor Yin may be interested in this. Namely, you see here, the space-time is preserved. So according to 20th century view, antimatter exists in our own space-time. Our own space-time. This no. Here there is a deep conjugation. Antimatter, because you have to conjugate also with this map the local space-time. So therefore, this means antimatter exists in a completely different space-time that coexists with us in our environment. We don't see it, but it coexists. That's the foundation of our hyperformulation of, namely with a multiple valued unit to represent this occurrence. That's the best way I can. Okay, now what is the birth of isodual theory of antimatter is, of course, Paul Dirac. And because I noted that in the gamma matrices there is a minus, there is a negative unit, 2 by 2 negative unit. And then I noticed that here there is an anti-Hermitian conjugation. The sigma are Hermitian, but when you do anti-Hermitian, you get an invariance. So the Paul Dirac equations are invariant under isoduality. But that was the birth to say. But then why don't we use this as a foundation of the mathematics? But once you assume that this is the unit of matter, of the electron, if you want, and this is the unit of the positron, the physical meaning of Dirac equation is changed. Because from representing only the electron, then the Dirac equation represents the tensorial product of an electron and a positron at the quantum level. There is no need of... We do the antimatter at the Newtonian level, so there is no need to go to second quantization. There is another reason why this. I have never accepted, I still have difficulty in accepting, since I was in graduate school, accepting 20th century interpretation of Dirac equation. Why? Because I knew a little bit of Lie theory. And you see, I'm told that this represents an electron with spin 1/2. But I cannot accept that, because I know of no irreducible 4-dimensional representation of the SU2 symmetry that has a spin 1/2. It does not exist. So then I say, okay, because irreducible representation is 2-dimensional. Then okay, let's look at a reducible representation. And there exists no reducible representation of the Lie algebra SU2 that has the structure of the gamma matrices. So I cannot accept the interpretation of the 20th century. I'm sorry, I respect, of course, I respect different views. The only algebraically consistent interpretation of Dirac gamma matrix is that it represents the tensorial product of one irreducible representation of SU2 for spin 1/2 and its anti-Hermitian, namely its isodual. But then we go back to the tensorial product of an electron and a positron. So there is a very deep. Now this is this implies, ladies and gentlemen, this implies revision of Feynman diagrams. This implication of this is very, very deep, because in Feynman you use Dirac equation for Feynman diagrams, but you dig deeper, and whenever you have antiparticles, we have serious problems in Feynman diagrams. Whenever the entirety of the mathematics, physics, and calculations for antimatter of the 20th century, ladies and gentlemen, it can be questioned whether it's correct or not, but there are serious questions. Well, the first thing is this number. You see, we have physicists. This Professor Silverstroff, beautiful emphasis on numbers, new numbers, unless we have numbers, unless this new mathematics is based on numbers, by this I mean sets that verify the axiom of a numerical field. If we don't verify the axiom of a numerical field, we don't. There's no physics that I can be of interest to me. It will not resist the test of time. But then it's very easy to see that if you change, if you assume -1, you wake up tomorrow morning, you have a fight with your wife. I'm tired of assuming the number 1 as basic unit. Professor Silverstone told you, okay, let's use 3 as a basic unit. Then you change the product and it's okay. Same thing here. You assume -1, you sandwich the inverse of the new unit and assume a new multiplication, and then you verify all axioms of a numerical field. Let's put it in a different way. Despite all the respect, for Cayley, Hamilton, that established the classification of numbers as real, complex, and quaternion, they missed numerous other realization of the abstract axiom. This is only one of many. The different way. There is nowhere in the axiom of a numerical field the condition that the unit has to be 1 positive. No, it can be an arbitrary number, positive and negative, Hermitian and non-Hermitian, single value or multiple values, and so on. This is, and keep in mind, though, that for a correct formulation, you have to conjugate the numbers themselves. In the first examination, no, there is no need to, because real numbers are both positive and negative, and the isoduality just inverse the positive and negatives. But be careful. This changes the mentality. Suppose you are an anti-particle scientist made of antimatter. You will have money in your checking account if and only if you are in the red by $2,000 or $3,000. If you are in the red, then you will have money. If you are if you have $3,000 in your checking account, this means you are up, because it is because everything is referred to a negative unit. So if you have positive dollars referred to a negative unit, means you are under. But if you have negative dollars referred to a negative unit, -$1, then you have money in the bank. So be careful. It's a total inversion of the way of thinking, and you have to get accustomed to. Okay, now I have to move fast because then this. I'm sorry, my voice is gone. Now to do physics, we have to do it. I should do a map to the totality of the mathematics that we use in physics of the 20th century. I cannot do it here, but it's very easy at this level of point particles. It becomes very complicated when we go to extended particle, antiparticle in the interior of an antimatter star, and then it becomes more complicated. But you apply the isoduality systematically to you miss one quantity, you don't conjugate, and you think you have an inconsistency. No, you have not applied it properly. Means the angle has to be conjugated, and the sinus and cosinus, but you look at this is indeed, this isodual functional analysis is indeed anti-Hermitian to the conventional functional analysis. That's what we need to treat neutral antimatter at the classical level, and so on for the differential calculus, you have to do it. Remember, Newton is Newton because he discovered the differential calculus. If he had not discovered the differential calculus, in my opinion, Newton would be a beautifully personalized epistemological philosopher, but not Newton the way we know him today. Here, unless you address the issue of the differential calculus, forget about it. And you recognize that the differential calculus throughout the 4th century was assumed to be independent from the unit. No way, no. Differential calculus is indeed directly dependent on the unit. In this case, you see the isodifferential calculus coincides with the conventional one, because you have a double conjugation of the differential and the variable. So it was hidden for a century, this new formulation of the differential calculus. This is crucial to represent, to have a Newtonian equation in honor of Newton, because this is Newton axiom, not mine. This is his axiom, only different realization, to extend Newton view from particles to antiparticles. This is crucial. Once you do that, then you do represent. And then the same for derivative, and then you have to keep going, ladies and gentlemen. You have to go to Lie algebra. Everything extends in a very, very consistent way. I apologize, but I don't have to. The space-time is also, again, you look at the Minkowski-Leonard, you will see the same thing, that is invariant under isoduality. So it's a map that was not identified, in the 20th century, because people never thought about this dual, conjugating everything. Only they conjugate space-time or whatever. But because the metric itself, you change the sign of the metric everywhere, you change the sign of the unit, and you have an invariance in Minkowski. So in this sense, our space-time coexists, but with structurally different. You will see the physical difference in a moment of this. It's very non-trivial, gentlemen. And then Riemann. Remember, we want to study the gravitational field of a neutral big Jupiter, made of antimatters, bigger Jupiter. We need a Riemannian formulation, of course. This is, of course, the Riemannian geometry, ladies and gentlemen. There is no change in the axiom. That's why it's called isoduality. Namely, it's a duality. Of course, we need it for antimatter, but isos from isostopos, preserving the original axiom in honor of the original master. But this, ladies and gentlemen, yes, we will see in a moment, this does represent the gravitational field of an antimatter. That's why this is the first workshop of an antimatter astrophysics. And I forgot what this is about, but essentially, this is when you do interior problem in antimatter, then becomes, then the iso unit becomes not only negative, definite, but becomes really complex situations, and I cannot. And then when you add irreversibility, you go to a higher level, and when you got multiple valued iso unit, you have multiple hyperstructure, however, our type within other unit. And that's essentially it, gentlemen. Everything I said is for point particles, and it's good enough to look at the foundation. The extended particle in the antiparticle interior condition, we can do it later on. Okay, now we have physicists, so we have to ask a few questions. So this is question number one. Well, suppose this is a star made of matter and this is a star made of antimatter. Question: do they attract or repel each other on gravitational grounds? This is the question. The question will very preliminarily answer on theoretical ground here. I will express you my personal view, but the important thing is the next lecture by Professor Dehaene, who formulated very scientifically, measure the gravitational field of the positron in the Earth, namely measure, because we don't know whether it goes up or down, and we will know. But this is question number one. We will address it this morning. Then the next issue which I have reservation for physicists since Einstein doesn't predict antimatter, then antimatter does not exist. This is no way, then, ladies and gentlemen. This is dangerous. The question is, this is a matter asteroid that we can see before it hits the Earth, because from matter light, which is the light from our sun. But the question is, if there is an antimatter asteroid, can we also see an antimatter asteroid by using the sunlight, which is matter light. Ladies and gentlemen, there are questions before throwing judgment. Be careful. Our safety is at stake here. So we have to have a scientific process rather than throwing judgment with no homework. And finally, now this question, the question number 2, I will try to address this after Professor Dehaene. But this is another question. Can we see with available telescope antimatter star or galaxy? If you use Einstein, no, yes, they don't exist. No, ladies and gentlemen, I want to bring it to a moment of reflection. The answer is not that clear. And so, conclusions is the universe could be full of antimatter galaxies that we don't see. It's a realistic possibility. And if the experiment that I proposed in 1994, and eventually Professor Dehaene is realizing thanks to also the intervention of my son, president of the Santilli Foundation, we are trying to get a minimum of $1 million funding from the European community. If that experiment says yes, that matter and antimatter repel gravitationally, then I have to correct what I stated yesterday. I stated yesterday that there is no expansion of the universe and no acceleration of the expansion. But if the universe is filled, that's why physics is so deep, is so polyedric, and I have to correct myself. I did this in purpose yesterday. I was silent. I couldn't mention anyhow. Because if there are matter and antimatter, the galaxy, and they repel each other, the universe is expanding because they push away from each other. That's why the complexity of nature is beyond our imagination, and we have to be very careful before throwing. Now, first, why we are doing physics now? Why do we need the S2 mass? Yes, we need. Because the contrary to the belief of the Eddington arrow of time, there are 2 directions of time. No, there are 4 directions of time. There is motion forward in forward time, motion forward in the past time, and vice versa. We have 4 times. So we need 2 conjugation to reach 4 of them. And that's so. At this level, the isoduality is the only one that I know. If you only use the inversion of the time direction, you will not reach all 4 of them. And then everything I have to move quickly from here on, and I apologize. But these are essentially the Newton's equation for antimatter particles. Point particles. We are talking about, remember, always we are talking about a point particle. You have to conjugate everything. Everything that you can possibly, including aberration, the product, of course, the quotient, of course. You forget to conjugate the quotient, you end up with inconsistency. So it's extremely elementary, but it's extremely tricky because we are accustomed to quotient. This is quotient, so in the calculation, we don't conjugate it, but then you have inconsistency. Because you mix one mathematics of matter with the mathematics of antimatter, that's a minestrone. It's like I want to study Newton's equation for a particle with isodual mathematics. It makes no sense, and vice versa. If you have isodual and Newtonian and you want to treat it with the conventional mathematics, you have a nonsense. And the same, you have to keep going. This is, of course, Lagrange equation. They conjugate very quickly, and they represent Newton equation. Of course, those that verify the condition of variation of self-adjointness that's been recalled by various people, including Professor Dehaene yesterday. Namely, those are basically derivable from an action principle. There is no external term. So we are here on exterior condition of antimatter, not interior. Interior, you will need a Lagrange external term. And so everything conjugate very nicely. Of course, at the relativistic level, also you have this Hamilton's equation. It's very tedious. It's absolutely elementary, but stupidly tricky that you have to look at all possible levels. And the same for quantum mechanics. Quantum mechanics conjugates beautifully, and we will see some of the implication in the following lecture. It becomes very tricky in beliefs of inconsistency. We have found none so far in this formulation. And then, of course, the Dirac equation, which I indicated to you, this new representation of positron strictly, specifically at the quantum level, avoiding, there's no need of second quantization. Here everybody, of course, will see, well, but Ruggero, this implies you go back to the old problem that Dirac is Dirac, that the positron has negative energy, violates causality, blah, blah, blah. No, ladies and gentlemen. The reason being because a particle, with a positive energy refer to a positive unit, such as 1 MeV, is exactly as causal as an antiparticle with a negative energy, let's say minus 1 MeV, but refer to a negative unit of energy. This is the unit, minus 1 as a foundation of everything. So you have to refer everything to this unit. Everything for matter, you refer to this unit. We know that. Now for antimatter, so a negative unit becomes fully acceptable. Motion backward in time, this becomes trivial, because an imaginary spaceship that moves backward in time is exactly as causal as a spaceship moving forward in time. With the understanding that motion forward in time is referred to the positive unit, 1 second, and the other is referred to the minus 1. So negative time refers to a negative unit. It's absolutely fully causal. We have all sorts of theorems proving this. Let me move quick. Professor Corda, how many minutes I'm left? I don't want to steal. Oh, okay. So I can breathe. Okay, so I'll. Then I would like to stop early, however, because the discussion, I would love to have criticism in particular. Okay, here we are at the equivalence of isoduality and charge conjugation. It is trivial, ladies and gentlemen. Trivial, but a little bit tricky. In other words, very easy to prove that everything you do with charge conjugation, you do it trivially in a Hilbert space with isoduality. But, however, you have to reach to apply isoduality all the way to the local coordinates, the units, etc., etc. Otherwise, you end up with inconsistency. Also, there are some hidden symmetry on the isoduality that help, and most of the processes are indeed we call it iso-self-dual. So therefore they are hidden in quantum mechanics. But this has helped us to now So what is the conclusion? The conclusion of the consequence of all this is that the isodual theory of antimatter, and before making the statement, I spent years of verification. To my best knowledge, the isodual theory of antimatter represents the totality of our experimental knowledge on antimatter, from classical all the way to the operator level, the accelerators, and we could find no contradiction up to this point. That's So let me look now at why we are now engaged in this major financial and scientific drive of measuring the gravity of antiparticle in the gravitational field of matter of Earth. Well, and for which, incidentally, all of you are welcome to participate. There will be a very large international team in which all of you, of course, especially because you have been part of the first workshop on antimatter astrophysics, so you are in a privilege. Let me be very, very straight. You will be in a privileged situation with respect to the others. So, the workshop has been announced all over the world for matter and antimatter, and with the summary, so they had everything, but they are welcome, of course. Everybody wants to participate. Now, here is the point. This is another point in which I spent checking and rechecking and stated in a couple of words. It's kind of dry. But according to the isodual theory of antimatter, the particle and antiparticle repel each other gravitationally, and this prediction is at all possible levels. There is no level taken possible from Newton to second isodual quantization. There is a prediction so if anti-gravity is not confirmed experimentally, isodual theory is wrong, and we go back to the 20th century. Namely, we have no viable theory of antimatter that applies at all levels. So it's a scientific catastrophe as far as I'm concerned, because I'm a democratic person. I believe in democracy among people. So certainly I want to implement democracy within matter and antimatter, which was absent in the 20th century. But let's see No, XD. D is the symbol of isoduality. Dual. T is time. T is time. Oh, G. This G here. Here? Yeah, D is the symbol of XD, not T. D like David. Yeah, this is the map of isoduality.
Why do you have a minus sign when you have that extra minus D?
Oh, because T is transposed. It's the symbol. Oh, now I understand. It's in that particular case. In other words, from a vertical column it becomes a horizontal. Yeah, sorry for. I'm moving very fast and lack of time, and this I apologize and for your. But for instance, you see here this is we're talking about now us, Newton, sitting on a nice, beautiful chair in England and trying to write the equation for what happened between a particle and an antiparticle. And there is only one antiparticle, so therefore you conjugate only the antiparticle, md. And what you get that the force is positive, which means repulsion. Then you have antimatter neutron and Newton. And then you work in a totally conjugated field, and then you look at the behavior of a particle. In this thing, everything has to be conjugated except the particle that you observe. So, and then again you get a negative value of the force. But the negative value of the force in the isodual space is repulsion, because it's referred to a negative unit. Because everything is conjugated, and so this, in this sense, is unavoidable. The repulsion between neutral. There is no charge. We're talking about mass without charge. This is a crucial point. The moment the charge, then you allow all sorts of manipulation of theories. No. We can add the charge trivially, but the point is we have to first achieve a formulation for a neutral particle. Then we add all the charge that you want. So this is basically the repulsion at the level of newtons. Now you do the same at the level of Minkowski. And again, I'm sorry here, this from a column this becomes an horizontal, bracket, and then you do everything. And you can see that the electromagnetic tensor will conjugate and represent repulsion. And finally, as the most important thing is at the Riemannian level. Riemannian level, provided you have formulated the Riemannian geometry in such a way that can represent the gravitational field of a classical and neutral. That's what. And I add the charge and conjugate the charge. No, it's got to be neutral. Then, if you do that, then you have a negative. In our world, we have a negative curvature. So therefore, that's anti-gravity. In their world, becomes positive, but referred to a negative unit becomes repulsion. So the prediction of anti-gravity, it is at all possible levels. If the anti-gravity is not confirmed, the theory is wrong. Period. And we have to restart from zero. Look at some other conjugation, and who knows what will require. Again, the implications are very serious. Not only for us, anti-gravity is the dream of mankind since a long time. Also, the implication, I have no words to express the implication. If the location where the anti-gravity, if it exists, and if it is confirmed, that location will become, my opinion, a place for scientific pilgrimage at least half a millennium, because the implications are beyond imagination. Talking about causal travel in time permitted, fully causal travel in time permitted by combination of matter and antimatter. Of course, not for matter or for ordinary matter or ordinary antimatter, no, for a very special form which we call isoself-dual. But the implications are beyond the science fiction of today. We're talking about traveling in space at arbitrary speed and new method of propulsion, which are not based on action and reaction. They're called isogeometric propulsion. It's beyond the scientific but this will be discussed by our descendants. I don't think we'll have a chance to present them. This is the proposal which I made in 1994. Let me review briefly. Very, Professor Dehaene, perhaps now we should close your ear because you are a very special scientist, very accurate. But I want to give you just a glimpse of the proposal. Namely, the proposal was the following. At that time, Fairbanks had tried to measure the gravity of positron by using, however, a vertical trap. And then his life was disrupted by his colleague. His wife was harassed in the middle of the night, and he had to interrupt the experiment because they were organized interest as luck. They did not want the experiment to go ahead. And the experiment was never completed by Fairbanks. Then there has been an obstruction against the experiment ever since. This has to be on record because the dark side of science in which we have to live, and of course treated with elegance but also with determination, because we are talking about, in this thing, we are talking about the safety of our planet. So there's a point that I respect this type of position, after which I intend to respond. So this was the proposal. Since besides the vertical is so difficult, you need a neutron interferometer, so we need a resolutory experiment. And that's the idea. So the idea was to use a tunnel. I think, I don't remember how much I proposed, 20 or 30 meters. Of course, super vacuum, with a super vacuum, of course, with a super...
Ruggero, 5 minutes.
Okay, this I think is the last... Thank you, Christian. So, of course, super cooled, of course. And with collimators, this is very, empirical. You will see now Professor Dehaene is much more technical in a scientific way. But the idea is you first send a photon. At the end you have a scintillator. So the photons in 10, 20 meters will not move in any appreciable way. So this is you see in the scintillator the point of no gravity. Then we send electrons, and I did a little calculations. If we send electrons that are the order of milli-electron volts, very, slow, exactly the opposite. Professor Ying, are you there? I don't know if you are, but anyhow, what he made yesterday, the comment, exactly the opposite of what they do at CERN. No, they were talking about milli-electron volts. Then you'll see the displacement down due to gravity, visible with the naked eye. You see with the eyes that the electron goes down. And then we send the positron. And we don't know whether, but it can go up or down. If it goes up, it's anti-gravity. If it goes down, then the anti-gravity does not exist. So basically, this is the end of my presentation, and thank you for your patience.
Okay, we can open the discussion. Question, Andrew. Then, okay, start.
Okay. First question has to do with your isodual Lagrangian mechanics. Do you still have the same, what you might call Lagrangian multiplier behavior as shows up in regular Lagrangian mechanics, or does that change?
I'm not familiar with the multiplier. Which type? I'm sorry.
Okay, it's not important. Okay, second question I had is, this is much more important. You had your SO13 would be locally isometric to SO, your tilde 13, your local isomorphic type of structure, which you're working with in terms of that type of group structure.
Anti-isomorphic.
Exactly. Now, what I'm asking is with respect to looking at the Einstein equations, or, your modification, looking at the sort of thing, and matter and antimatter and everything is the locally isomorphic type of structure important to the matter-antimatter type of problem?
Yes, this is the very fundamental issue. But it's not isomorphic, anti-isomorphic. That's why it's called isodual, because you need the duality to go from matter to antimatter.
Okay, so the important issue is the duality then.
The isoduality. That you do a dual map, but always preserving the original axioms. The numerical field, the axioms are the same. You have a different in the Riemannian geometry. The geometry is Riemann. Only you present a different realization, which is hidden in. If you look at the line element and you apply the isoduality, the line element in Schwarzschild is invariant under isoduality. So basically, it's very easy to reformulate it. Incidentally, however, careful that this invariance requires that the line element is an isodual number, which necessarily has to be multiplied by the iso unit, is isodual unit, which is -1. Thank you for your question. Yes, indeed. Criticism, please. No, thank you, Professor Berkowitz. I appreciate your question. Oh, I'm sure you have many. Yes.
Yeah.
Thank you.
Yeah.
Go ahead.
It's quite clear what is a particle and what is an antiparticle if you're looking at fermions, but with bosons it's a lot more difficult to distinguish. For example, the K boson is conventionally considered to be a combination of an down quark, and an anti-strange quark, whereas the K bar, which is considered to be its antiparticle, is a strange and an anti-down. So do you consider those matter or antimatter? Because it's not obvious to me which they are.
Professor Roland, this is a very, very deep question that illustrates the insufficiency of my presentation. Let's look at the pi zero. The pi zero, I don't believe in quarks, but let's call it, most certain the pi zero is a dynamical state of let's call it a parton and an antiparton. So according to this theory, the pi zero is, in our language, is iso-self-dual. Namely, it is invariant under the duality. It's the same, strangely enough, like the Dirac equation, because the Dirac equation for us is a direct product of an electron and a positron. So back to your issue, those iso-self-dual states are very, very intriguing. You put the finger in a very intriguing. Now this is it's a question of calculating the energy, and the mysterious part of this you will see this in the next lecture. The intriguing part is that of those mysterious states made of equal amount of matter and antimatter, then they are attracted in the gravitational field of matter, and they are attracted in the gravitational field of antimatter. Yes, it's a very mysterious, because in other words, and I will show you the little equation in the next lecture, but you can see it visually. When you compute the Hamiltonian of the particle, you have Hamiltonian multiplied, careful the operation, multiplied by the Kepler. Okay, and you get equal to energy, positive energy. Now, if you have the isodual Hamiltonian, becomes multiplied. Now you have to conjugate the multiplication. So you end up with a positive energy too. So you end up with a positive energy, therefore attraction in the field of matter, and attraction also in the field of antimatter. Very mysterious. That is why the time travel is causal, precisely for the isodual particle made of such as the pi zero, the K zero, and many others. When you go, then you hint to an even higher level of, much higher level of complication, which I have to say I don't know, because you added other particles, if you add charms and other things, then sorry, we have not reached that level of, but there are still lots to be done. Oh yes, you touched the finger in one of them. Thank you. Okay, criticism, please.
And now Professor Siawar.
You have mentioned in your talk the question if light from the sun hits an anti-asteroid, if it can be seen or not. And you emphasize that it's light from normal matter, from our sun. Do you think that there are antiphotons or anti-electromagnetic waves? And if so, how are they going to look?
Again, this is a fantastic question. It shows the gross insufficiency of my presentation. This is a summary of many pages, many years of work. You see, the target, this will be better focused in the lecture after Professor Dehaene, but this thing is so fundamental. Your question is so important that it deserves a minute with the approval of our chairman, Professor Codd. You see, you have to look at what is the target of all this exercise. The target is to achieve a geometric, mathematical, and physical differentiation, a quantitative difference in the quantitative treatment between a neutral matter and neutral antimatter. Because the addition of a charge is totally trivial. You have a high school student do it. Now, once you have achieved this differentiation between a neutral matter and antimatter, the differentiation between light emitted by matter and light emitted by antimatter is unavoidable. With physical, not epistemological difference. No, very, very physical. One of them very verifiable, not only for polarization and parity, all this. No. This theory predicts that light emitted by antimatter is repelled by the gravitational field of matter. And this is a prediction that could be verified or dismissed in astrophysics. If we open our eyes and look at the sky a little bit different, this will be my next lecture, but there will be a possibility of verifying, because nowadays we can see whether we have a bending of light, that's the normal gravitation, or anti-bending. It's predicted by Newtonian universal gravitation. You introduce other than a mass. Light has no mass, but you introduce the energy. That's the way I use Newton's equation. For me, Newton's equations, gravitation is universal. Being universal must include also light, otherwise it's not universal. The way I've done this since graduate school is by rather than using mass, I use the energy equivalence. Once you use the energy equivalence, and immediately you have seen the repulsion. The equation which I showed to you before for mass applies also for light. And you have a mass that you look at, we call it isodual light, it is repelled by, there is no way. This theory predicts different, it is this difference of the light emitted that creates problem in detecting antimatter star, and it's an open problem. You will wait the next lecture after Professor Dehaene. You will see some fundamental unanswered questions. But thank you for asking this issue. It's very fundamental.
Professor De Souza? Okay. Professor Udrist.
Let me to formulate, I think, a stupid question.
No question.
When we speak about matter and antimatter, automatically in our mind is in the left is matter, in the right is antimatter. Can you explain, it is possible, in fact, matter is the same with antimatter, but perhaps depend how we look. In my opinion, we cannot say here we have an asteroid of matter, here another which is antimatter. In my opinion, is the same, but depend how we look, how we judge, what conditions to transform this object into, let's say, Tunguska catastrophe and so on. Depend. I don't know what kind of physics we applied.
Well, that was the attempt that again. That's what we have tried in the next several years, decades, 2 or 3 decades of work. You have to again. We are physicists. Unless we do quantitative treatment, we do philosophy, and I have no interest. So I need equations predicting numbers. The numbers have to be invariant, and they have to be verifiable with experiments. This is the whole essence here. Now, to do this, to do mathematical treatment, predicting numbers, you need a theory of antimatter. Without a theory of antimatter valid at all levels, you do philosophy. So the question, so your question is, so this is one theory of antimatter that first of all, holds for classical and neutral particles and stars and asteroids, number one. Number two, holds at all levels, from classical to and number three, verifies all experimental data. Now, of course, not necessarily is unique. The beauty of physics is polyhedric. So I would recommend you to look for another theory, but you have to work out a theory. Otherwise, just by idea for you or me is the same. It's not enough to do physics. Now, if you look for an alternative theory, be careful, because, for instance, there are very hidden these things is so trivial. Isoduality. You change the sign, you do the anti-hermeticity. These are very, very deep things. For instance, isoduality of coordinates in Euclidean space have been proven to be non-equivalent to parity. So we're talking about a real new conjugation, very, very deep into the structure of space-time. And the end result is that you end up with you are forced to assume that antimatter exists in a space that is in here. But because there could be another, let's hope not, but there could be antimatter asteroid passing nearby, let's hope not. But space-time coexists with ours, but they are profoundly different, physically different, with repulsion and many, many other things that you can differentiate with experiments. So this is my advice. You've got to work out the theory, otherwise, in other words, this all started because when I was at graduate school, I was looking at the picture from the galaxy, and I want to know whether such and such galaxy is made of matter or antimatter. So I started looking at Einstein, gravitation. I immediately discovered there was nothing I could do, because there is no distinction, and so that's why I started. Well, but we have to some days we should be able eventually to work out something. This was a dream of 40, 50 years ago. The dream seems to be coming true slowly with the idea of the isodual photon. Because if after the test that Professor De Annis will present on the gravity of the positron, the next test is to see what is the behavior of light emitted by antimatter. If light emitted by antimatter is repelled, which will be inevitable in case he confirms anti-gravity, then we'll finally be able, after one day in the future, to see, if you see a galaxy far away and you see the light, you'll be able to see whether it is ordinary light or isodual. So finally we may have a way of differentiating whether the star is made, and that's the main target of this. This is why this is the first workshop on antimatter astrophysics. This is the open issue. I would love if you can address, Professor Corda would love to have a separate session on matter, astrophysics of matter in the proceedings, and then the separate part 2, and we'll love contribution in this issue. Any idea is welcome, because it's terra incognita. There is so much to be discovered. The 20th century, what has done in antiparticle is ridiculously minuscule.
Wait. You have stressed several times that you're sure there must be an ether medium in order for all kinds of functions. Now the question is there also an anti-ether? And if ether should be the base of matter, is it also the base of antimatter? So there is kind of a neutral ether which can be at one side matter, or create, or whatever, be the base of, and on the other side of antimatter?
This question is so deep that goes outside our capability of quantitative treatment. I can only hint at some possible. I've never studied. I can tell you, however, this is my personal conviction, that ether is a universal medium with physical characteristics, such as rigidity, because the light is transverse electromagnetic wave. So you need very high rigidity. That's why it allows the prediction of longitudinal communications at millions of times the speed of light in vacuum. But and this medium, if you do the calculation, is an enormously high energy. Talking about in 1 cubic centimeter, you have, I think, 1 million times the energy of the entire sun. Numbers are beyond imagination. Incidentally, you should know that hadronic mechanics has been worked out. One of the primary reasons is to work out the structure of the neutron, the synthesis of the neutron in a star. Unfortunately, Professor Corda, I don't know whether I will have time to present this. Professor Animali was supposed to present this, but I don't want to steal time to.
I remember.
The point, however, in that case, you miss about 0.8 MeV, where it's coming from. If it comes from the star, a star will never, ever initiate producing light, because at the moment it starts from pure hydrogen, and then before produce light, you need to synthesize the neutron. Neutron is 1 million MeV, And if you give it to relative kinetic energy, proton and electron, the cross-section is 10 to the minus 30 bar, so zero. You will never synthesize. So where is this million coming from? Million MeV. The only solution that I know, after working at this for years and years, is from the ether. It's the first time of interchange, the first interchange of energy between the ether into our world. The isotopy of the Hilbert space have been presented. You cannot do this with the Hilbert space. Forget about Schrödinger, blows up, quantum mechanics, totally gone. Why? Because the mass of the neutron is bigger than the sum of the mass of the proton and the electron. So you will need a positive binding energy. The initial equation of Schrödinger, Heisenberg, you will, with quantum mechanics, that's why nobody has ever studied. For the 20th century, the synthesis. So let me make my point. So back to the matter side, because we are physicists, we have to treat quantitatively your question. So I tell you up to which point, and then becomes epistemology. So the isodual space, isodual Hilbert space, has been worked out precisely for this transition of energy from the ether. Now, back to your question, this theory, now we enter into epistemology, I have to stress, because sure, we have here the isodual Hilbert space, but the prediction is that basically the ether is a superposition of this positive structure, let's call it structure, we don't know what it is, that propagates electromagnetic waves, and it's isodual that propagates the isodual light. And that is the prediction. I'm sorry? It's a coexistence of entity in the same region throughout the universe, will be throughout the universe. And if that is true, then we go beyond the science fiction, because already now we have a computerized model of spaceships at arbitrary speed, millions of times faster than the speed of light, to cover arbitrary distances without fuel tank, by using mechanism of extracting energy from the ether, not from the vacuum, the quantum vacuum. No, this is dramatically different. And this effect, one of the importance of Professor Nim's experiment, is what we expect to be a longitudinal contribution. Then this exchange of energy between ether and matter is longitudinal, so it's dramatically beyond special relativity. So the speed is totally unlimited. You look at the geometry at the distance of a star. You control the distance of a star in any way you want, because it's called isogeometric propulsion. It's beyond the science fiction of today, I can assure you. But we have crossed the quantitative physics and entered into dreams. I have to be honest on this. Thank you.
Professor Burinsky now.
It can be considered, for example, Feynman diagram, and there is loop from virtual photons which are connected electron with past point of electron which can be interpreted as positron. So in this picture we can consider as virtual photons which connect matter and antimatter. And because of that it seems that virtual photons, it's electromagnetic Maxwell field really, can connect matter and antimatter. It seems that it is indication that electromagnetic dual and isodual should not be different too strongly. It may be the same field, but maybe with different energy. So it is supposition. Maybe I don't know what is the opinion about this point.
Yeah, you touched a very, very delicate point. I have to allow me. We are among friends. Please don't accept my view. We are a democratic environment. I'm sorry. I cannot accept Feynman diagrams whenever there is an antiparticle, including beginning with the mediation. I have problems. This was addressed in Kathmandu. And it is in the proceedings. The problems. Let's think it this way. Suppose you have a scattering between particle and antiparticle. Then you introduce this photon, but then you violated democracy between particle and antiparticle. So then, because the photons is physically different in size of dual, so you have violated democracy. This violation is not just psychological; it goes down to numbers. But then, oh no, then I have to restore the democracy by also adding an exchange of the isodual photons. But then you exchange one wire. You have all sorts of problems. They are fundamentally unsolved. I believe, it is my opinion, that the diagrams, the formulation of the Feynman diagrams for antimatter are fundamentally open at this moment. I do not accept them. I have a long list of objections. So the answer to your question is, if you try to do the calculation, you will end up in inconsistency. Also keep in mind that you have a symmetry here. So you start from particle, antiparticle. This is iso-self-dual. It's a new symmetry that has to be verified in, but this has to be verified also for intermediate states. Let me put it in a different way. The very idea, if you want to know the whole thing as it appears to us, when you have particle and antiparticle, the very idea of exchange of virtual is gone. Why so? Because the moment they are separated, you don't need them. The moment they coalesce, then the very idea of an exchange is gone. They annihilate. And those are contact interactions, zero range, zero range. Suppose you introduce a particle, you don't have time to propagate it, because by the time you try to propagate it, the system has already do the calculation, the system has already annihilated. So the very idea of exchange is gone. The very, very essence of the diagram is gone in this particular case. This is not the case for particles, no. And then this Feynman grams. Incidentally, with the calculations up to empirically to end up with the same thing, but the real experiment on it is my opinion also, if you want to know the whole thing, that the Feynman diagram for the prediction of the Feynman diagram for antiparticle have never been experimentally tested, because there are predictions of substantial deviation. The theory, once you achieve equality between matter and antimatter, Feynman diagram for antimatter are gone, because they don't keep this equality. This is my opinion, and I pray to be wrong, but this is my opinion. At the same time, I am a physicist, with all due respect to Feynman, but I have to admit, with the best of situations, with the best of my knowledge, without politics. That's why I couldn't care less about the chair at Harvard. I care about knowledge.
Again, Professor Beckwith.
I remember what you said about the meteorite hitting Siberia in 2008. All right. Now, I presume is that the origins of the antimatter meteorite, if that's what it is, were in the asteroid type of belt. Could there be a farther distance, let's say, for where the asteroid came from? Or would it just have to be a relatively local type of phenomenon for generation of the asteroid? Okay. Where would you expect that asteroid the antimatter asteroid to have been created? Secondly, is that if you have a distance, a much longer distance to travel than just going from the asteroid to Siberia, would there be any consequences for the antimatter in that situation?
I did not understand the second question,
okay.
Sorry.
My question is that you have an asteroid that you said is antimatter asteroid, which hit Siberia. Okay. Now, if you say it could be generated or created in the asteroid, but I assume you're between Mars and Jupiter. I assume that's where you're saying it was created.
No. This, as you will see in the next lecture,
or it could be farther away.
I show you that the nebula is predicted to be...
Okay, well that's the reason. I thought it was going to be much farther away, because I could see that there would be some sort of a problem if they're created locally.
The prediction is that there exists antimatter galaxy in the universe. And simply we do not see them for reason we'll see in the next lecture.
But you're saying something that's very far away would be the genesis.
All evidence that we have, our galaxy is made of matter, and our planetary system, including asteroid belts, is made of of pure matter asteroid. Otherwise, we will see very frequently explosion in our system. So the evidence is very, very strong. We live in a matter planetary system.
So it's
Any other
very
question?
far away from the asteroid.
Yeah, far away from galaxies.
Okay,
far
that
away
was my intuition, but I
Yes.
wanted to confirm.
Thank you for asking this important question, Professor Beckwith. Thank you.
Professor Cometti.
All questions are important because it's terra incognita. We live in a physics that was totally ignored for an entire century. So the questions are endless. Okay.
It's difficult to agree that Feynman diagram has never been tested in experiments. Take, for example, lump shift, where the multi-loop contributions are taken into account and an agreement between theory and experiment is perfect. To me, this is just an experimental test of Feynman diagrams. Lump shift in simple atoms.
Honestly, I have not studied. This was very briefly touched during the Kathmandu meeting. There is a paper in the proceedings I would recommend to look at. The proceedings are available in free PDF download. And it's a very deep question because it's a very strange situation. In certain cases, the outcome of the Feynman diagrams are fully compatible with isoduality. In other cases, we have difficulties. Which one, honestly, I would not know at this moment. But one thing is certain, that the exchange, the idea of exchange, when you have particle-antiparticle is in question. That is, I'm certain about, because there is no time to propagate. The moment the wave packet, they touch with each other, they annihilate, and there is no time for the propagation of a virtual, for the existence of a virtual exchange particle. That is the main point in particle-antiparticle. But this does not mean that the Feynman diagrams eventually may work very well with the approximation of mediation of a photon, because in Feynman diagrams everything is a point. Wave packets are points in Feynman. This is with the reservation. I do not believe there exists a point-like wave packet. The moment you admit an extension, already you have problems with particles. But the moment you add antiparticle, oh my God, there is annihilation. Then you see the dimension of the open question. Oh yes, you have no time to propagate virtual particles because the contact zero range. Sorry, because you have to go to the next lecture.
Professor Gill.
Just a brief comment.
Brief question, please.
Just a brief comment on the Feynman diagrams. Feynman diagrams are actually just a mathematical device developed by Feynman to give a description to the perturbation expansion in QED, an interpretive description, assuming exactly as you say, that first of all we have point particles mediated by either photons, or in that case photons, and in the standard model various different kinds of particles. But it has nothing to do with the problem of calculation. As a matter of fact, you can compute the Lamb shift without the Feynman diagrams.
Yes, that is correct. Yes. Professor Gill, you should look at this very short notes, and you are an expert in the field. You should look at, if we have time to discuss this open issue, because it may well be that the Feynman diagrams work very well also for particle-antiparticle annihilation. It may well be. I do not exclude. Also, there are certain unresolved issues